the students are different too, but I don't know if the students are different because children are different these days and society is different, or whether UD students are different. I mean, it's hard for me to say whether it's UD or not.
How are they different?
So this is a personal thing for me. I'll give you a personal example. In the year, I'm going to say 86 or so, 1986, I had a group of students who much later, when I was going up for a promotion or an award or something, one of them wrote a letter of support for this award that I was to receive. And he explained in that award that Dr. Higgins didn't take no from us in terms of doing better or doing as she expected. So if we got low grades on a test as a class, then you could bet on the fact that she'd walk in and give us essentially a pep talk and say, you can do better, I know you can, and you will do better. And he said the outcome was generally, we did do better on the next test. I don't believe I've changed that much as a teacher, but I do know now students simply saying, she yells at us when we do badly on a test. They will actually write this down in their evaluations. And so what one group so many years ago saw as a pep talk, in general now students see as a scolding, as a judgment, as I don't know what, but they don't necessarily do better either, because then they're not taking it as a pep talk. So I think that is a big difference. I feel like I'm expected more to get the students to realize that it is in their best interest to be doing. And I am by nature an impatient person, and I also believe that if you're paying the gobs of money you are to come to this place, then you are actually expecting to be raised to levels that you didn't even know you could achieve. And I'm really not seeing why this should be an impediment to any student at all. Of course, part of it is the approach in mathematics too. So that I guess the change in UD, how faculty are hired, the change in the students, but you can't separate those changes or look at them without looking at society as a whole and the disciplines. So in mathematics, it's now less of lecture, less of sage on the stage, and more of let's be with them and have the students be engaged in what they're doing. So, so yeah, there have been more attempts, and I don't think that I try not to do things that are faddish. So I try not to pick up on something just because a whole bunch of other people are doing it. When I hear about some new technique in mathematics, I want to first hear from other faculty who've actually used that in their classrooms and hear from them where this worked, how did they do it, so what were the logistics, and what did the students get out of it that they didn't get when doing it the old-fashioned way, let's say, and did you actually learn something more about your students' either ability to grasp things or time they took, etc. And if all that seems like there is a definite benefit, then I will do it. So I rarely do things just for doing them. But I do look for interesting projects and things for students to do, involve them in technology and mathematics. Mm-hmm. Well, most teachers, I think, teach because of that moment when you see a student who's just sitting there suddenly go. And that aha moment is what gives us all satisfaction. So this happened a lot then, it happens a lot now. It's just a difference. So no, I don't think there were some funny moments that were silly, but they don't necessarily deal with teaching. So for example, I was only 25 when I started teaching here, so I was not that far away from many of the students' ages. And of course, we are much more inclusive now. And our students come from a certain background, so they weren't particularly used to this. And once a student told me this, a male student told me, that when he first walked into his Calc 1 class, and I got up there. He knew that a Dr. Higgins was going to teach him, but I walked in a sari with my dot on my head, and he just went, oh no, I'm going to have to sit through a semester of not understanding this person at all. And the reason I'm telling the story is it didn't really shock me that it happened. In fact, I sort of expected it would happen. But I'm confident of my English, and so I didn't have any problem. He was one of the better students, and when he told me the story 3 or 4 years later, it was something we all laughed at because he took several courses with me afterwards, and so clearly he got over whatever he was experiencing. But I do like to dress up in my Indian clothes and shock students on the first day, because Higgins doesn't actually bring to mind the image that you see in front of you. And so that's a nice jarring of, in the beginning I didn't do it deliberately. Now I do it deliberately as a way of reminding people that not everything is as you think it's gonna be. So certainly I believe that it's my role to be prepared and to give the students what they came in for. And in mathematics, I think it's particularly, it's easier maybe than in other disciplines, though I can't say because I haven't taught in other disciplines, but I mean, the work seems more cut and dried. When we talk about a syllabus, there's actual content that has to be delivered, and that has to be delivered somehow. It's my responsibility to pick good books, to good textbooks, and to, provide enough support to the students, but I think also enough challenge. And I think for me, it's less that every student should get an A or should excel, but every student should be measurably more knowledgeable and confident in mathematics when they leave the lecture, the classroom, the course, than they were before they came in. So that somehow must happen. Does it always happen? No. What is the student's role? Well, I think students should always be interested, be questioning, and even if they couldn't care less, and there are students who don't, I think they still have to decide that this is a discipline. In all we do in life, there are some aspects that you really like, and some things you just have to do because you have to do them. And it doesn't help anybody to be grumpy about it. Everybody has these things that they have to do. You just do them, and you do them the best you can. And I think actually we teach a course here in the math department called Contemporary Mathematics. This is a course taken by liberal arts students. I'm going to say horn majors because I know several people who are horn majors, but I mean this generically. They're social studies. They're non-science majors who need to take one math class. And we actually changed the class. Instead of teaching them pre-calculus, which is a funny name for a course because it implies that you're going to take calculus afterwards, and very few of these students were going to, in fact none. So anyway, instead of making them do something like that, we came up with this contemporary mathematics. Many colleges around the country are doing it. UD is not unique in this. In there we teach them, for example, voting theory. So this is something that anybody watching this tape can understand. And the way I teach it, I'll give you the example of. So you're going to get two things in this next little segment. You're going to get the content of something that's interesting to people, and then there's also how I do it in class. So the idea is this: if you ask 25 people to vote for 4 candidates of some kind, and when I walk into class, I say, we're all going to go on a class picnic. We're not really, but let's pretend we are. And we can only take one kind of pop with us, one kind of soda pop. So name me 4 things. Somebody calls out Coke, Pepsi, Mountain Dew, whatever. And we'll all vote on them. And the way we vote is we rank them. So everybody does this without telling anybody else. And then I ask every student in class to give me their ranking. I put it up on the board. And then we talk about what we can do with this ranking. And for most students, they think that's where the voting stops. Is you go to the booth and you check off your choices, or fill in the bubbles, or whatever it is you do. But actually what this segment in the syllabus does is it shows that how those votes are counted makes a big difference. So you can come up with 15 people said Coke number 1 and 12 people said root beer number 2 and all the others were smaller than that. So Coke wins. But if there were actually 40 people voting, then you only had 15 people. The largest first place vote was only 15 people, and that's not even a majority. So the question is this fair? Are we really saying that just because Coke got the most number of votes, that Coke becomes the choice? Might it not be fair to start eliminating the ones that got the least number of first place votes? Or I said that wrong. The most number of last place votes, let's say. So if 38 people don't want Dr. Pepper or put Dr. Pepper as their last choice, shouldn't we just throw it out and go with the others? And there are several different voting schemes where you count up. And in fact, in good textbooks, what they do is, this doesn't always happen in the experiment I do in class with the soda pop, but most textbooks have a cooked up example where you perform the 4 or 5 different methods that the book is trying to teach you, and you get a different winner each time. And then that shows that you're not messing with the ballots. The ballots were what they were when you went to the polls and put them in. It's what happens afterwards. So it's important to know, are you going to use this method or that method before? And then the questions of how can each method be manipulated and so on. And this is interesting. This ought to be interesting anyway, even if you're never ever going to actually be in government or do something like that. And the students who are intellectually curious do find this interesting, and that's what makes this course fun for me to teach. It's not so much that we're trying to teach them something that they will use later. Some faculty on this campus, in our campus-wide discussions, have said that a course like this that's compelled to be taken by non-science majors should teach them how to calculate their mortgage. And I can't think of a more boring way of showing somebody how mathematics can be useful than making them calculate their mortgage, especially when technology can do it for you these days. You just have to make sure that the technology can do it right. But other than that, it's not an interesting thing to do.